Today's lesson is over 11.6, similar figures. Our goal today is to be able to determine whether figures are similar and find missing lengths in a pair of similar figures. First, we need to start by understanding that a similar figure, if two figures are similar, then the corresponding sides are proportional and the corresponding angles are congruent. So we're looking at congruence and proportionality. So if I have a figure, we'll start with a rectangle, and I have a second rectangle that's bigger, our corresponding sides are the sides that would be similar to one another. So the long part of the rectangles would correspond to one another, and then the short part of the rectangles would correspond to one another. Our corresponding angles would be this angle and that angle. So just whichever ones match in the other shape. Corresponding means that they match one another. So a little bit of vocabulary. Figures that have the same shape, but not necessarily the same size, are considered similar figures. So we need to learn how we can identify whether or not figures are similar. And we're going to do this using proportions. First, before we even start to identify which ones are similar, let's look at the different figures and figure out which sides are corresponding to one another. So FG corresponds with LM, AB, and QR. Those are the long sides of the rectangle. The short sides of the rectangle, GH, MN, BC, and RS. So now you can see which sides correspond with one another. We're going to compare the ratios of the corresponding sides. So first we look at, we're going to compare with rectangle LMNO, and the length FG corresponds to LM, and that comes out to 9/8. So 9 over 8. Now GH measures 3 and MN measures 2. So what I want to know is, does 9/8 equal 3/2? In order for these to be similar, this must be a true statement. This is the proportion, the ratio of the corresponding sides. Well, I can do several different ways. I can do cross products. 8 times 3 is 24. 9 times 2 is 18. If the cross products are not equal to each other, then no, it's not proportional. Okay, let's look at ABCD. So we're going to compare the ratio of FG to AB. FG measures 9, AB measures 6. So now I have 9/6 and 3/2. Are these equivalent ratios? Well, 2 times 3 is equal to 6, and 3 times 3 is equal to 9. So since I can multiply it by a form of 1, 3/3, and I get equivalent ratios, so yes, these are proportional. Rectangle ABCD is similar to QRST. I'm sorry, ABCD is similar to FGHI. Now we're going to look at the next rectangle, that's QRST. So we are comparing FG and QR, which is 9/12, to GH, which measures 3, and RS, which measures 6. I'm going to simplify these. 3/6 is equal to 1/2, and 9/12 is equal to 3/4. 3/4, does that equal 1/2? No, 2/4 would be equal to 1/2. So these are not similar. So rectangle FGHI is similar to rectangle ABCD. Now you try. Which rectangle from the previous example is similar to rectangle WXYZ? Go ahead and pause it, take a minute to work it out, and come back to me to check. Okay, so I'm comparing these ratios, and I'm going to compare WX to FG. WX is 4.5. FG is 9. And then I need to look at XZ and GH, and that is 4 to 3. Now, so then we compare 4/5 and 4.5 over 9 to 4/3. Well, 3 times 3 is 9, 4 times 3 is 12. So no, it is not similar to FGHI. So now I'll look at LMNO. WX is 4.5. XZ is 4. Then we look at LM, which is 8. I'm sorry, WX, yeah, LM, which is 8. And MN is 2. 2 times 4 is 8. 4 times 4 is 16. These are not proportional. If we look at ABCD, WX is 4.5. And AB is 6. XZ is 4. And BC is 2. 2 times 3 is 6. 4 times 3 is 12. So these are not proportional. And last but not least, we're looking at QRST. So we're comparing 4.5, and then QR is 12 to 4 and 6. 6 times 2 is 12. 4 times 2 is not 4.5, it's 8. So it's not proportional to QRST either. So the solution to this one is neither. None of them are similar to WXYZ. Okay, now we're going to look at similar triangles and comparing similar triangles. So if triangle ABCD is similar to triangle DEF, we're going to find the length of DF. Since the two triangles are similar, the ratios of their corresponding sides are proportional. So you can write and solve a proportion to find the length of DF. Our corresponding sides are CD and BA, AC and DF. So first we're comparing AB to DE. So that is 3 over 4 equals 11 over N. And this is what we're solving for. N represents the length of DF. So I cross multiply. 3N is equal to 44. Because we're multiplying, 4 times 11. Then we simplify. We are going to divide each side by 44. By 3. So 44 divided by 3 is equal to 14 2/3. So the length of DF is 14.67 centimeters, or 14 2/3 centimeters. So we divided each side by 3 because we need to get the N by itself, remember? So we divide by 3, divide by 3. Here's one for you to try on your own. While you work it out, go ahead and pause the video, then come back to me to check it. Okay, we're looking at triangle JKL. We want to, and it tells us it's similar to MNO, and we want to find the length of JL. So JK corresponds with MN, and MO corresponds with JL. So we want to set up the ratio JK to MN, JL to MO. This is what we're solving for. So the length of JK is 6, MN is 8, JL is what we're solving for. I'm going to substitute N for JL, and 18 is MO. Okay, to solve this proportion, I'm going to go ahead and say that I know that 6 times 18 is equal to 8N. 6 times 18 is 108. Divide that by 8, and now I have 13.5. So N is 13.5. I hope you had a lot of success. Go ahead and rate yourself 1, 2, or 3 star, or T for tutorial, and we'll see you back in class